Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Ar-Rahmanir-Rahim. Maliki yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Right. Before we go further, I would like to know whether Adam Arif here. Adam Arif. Adam Arif. Two Adam Arif. Adam Arif Syahrul Adnan. Adam Arif Fazil. Is that here?
Ada.
Okay.
Ada, sir.
Adam Azra'i. Adam Azra'i. For those, Adam Hakimi, Adam Harith bin Abdul Rahim, Adam Harith bin Abdul Rahim.
Yes, sir.
Ahmad Azib Danish. Ahmad Azib Danish. Ahmad Azib Danish. Is that here? Ahmad Azib Danish? Ahmad Azib Danish. Okay. For the people I call their name, just call their name. Right. Adam Arif. Who is Adam Arif? Adam Arif bin Syahrul Adnan.
Me, sir.
Okay, for the next time for quiz, we will have quiz for the next week, right? For next time, please submit to me the answer in single file. Because your previous OBT, I can see that you submit in different file. Question 1, you submit. Question 2, you submit. Question 3, you submit. Question 4, you submit. Please submit in single file. And when you going to submit? In question, the last question. The last questions. You submit and submit to me in single file, which consists of number 1, 2, 3, and 4. If you have 4 questions. You understand?
Yes, sir.
Because I got problems of this name. Adam Arif bin Syahrul Adnan, Adam Arif bin Fazil, Adam Azra'i, Adam Hakimi, Adam Harith, Ahmad Azib. The rest, no problems. Because they sent to me in single file, right? For those names, already I can solve your problems, but I have to search one by one. You understand? So for the next one, quiz and OBT, you only, even though the question appear one by one, you only submit one file to me in the last questions. In last question, like what your friend did, or your friends who managed to submit in a single, so I can see all the question in one file, right? Okay, right. Thank you very much. Right. So chapter 3, we just finished chapter 3, and remember that next week we have quiz for chapter 3. next week. So you submit to me in single file. Not say that when question 4, you just submit question 4. All the questions you submit on that. Not question 4, the last question. I don't know what is the last question for the quiz next week. Either question 4 is the last question, or maybe question 5. Don't know yet. Because I don't know the question. To be honest, that I don't know the question. Not me to make a question. Okay. And now we go to chapter 4. Chapter 4 is about exponentials and logarithmic function. So this chapter will divide into two parts. One, we focus on exponential, and then we focus on the logarithmic. And the last one, we got the resolve the equation which including exponential and logarithmic, only exponential, or maybe only logarithmic, or maybe both. In one question, both we need to use exponential and logarithmic. And then we look at the exponential function first. Before we go to logarithmic, we look at the exponential first. So exponential functions, by the definition, exponential function represent by this. The function which is represented by a to the power of x. So the exponential function, this is the exponential function with base a. This of the exponential function can be anything but a to the power of x, base a. So exponential function, you remember that for the function, one-to-one function, the function, what you say? So exponential function is one-to-one function. It will be one-to-one function. When we talk about one-to-one function, that function must have what? Must have what? Must have what? Must have what?
Must have inverse.
Must have an inverse. Which means the exponential function has an inverse. Exponential function is one-to-one and must have an inverse. Because it is one-to-one function. Later, we're going to find the inverse of the exponential function later. Now we forget for a while. Remember that exponential function must be in this form. This is the exponential function with base a here. A here can be any number. Can be any number. A here can be any number. Where a must be greater than 1, greater than 0, and a is not equal to 1. A must be greater than 0. And a must not equal to 1. That's the conditions. A must be this. Greater than 0, a must be not equal to 1. A must be not equal to 1 and a must be greater than 0. So the value of a here, if we look at the definition, must be positive number. A must be positive number. Right. Okay. Remember that we know in exponentials. Then we look at the exponential function for a is greater than 1. For a is greater than 1, the graph of the exponential function will be like this. This is x, y. The graph of the exponential functions, where here will be 0.01. The graph of exponential function. This is x, y. For case a is greater than 0, for case of a is greater than 0. Remember that the function is a to the power of x. For case a is greater than 0. So domain, what is the domain of these functions? Remember that we have asymptotes here. Asymptotes here. So what is the domain of this function? What is the domain?
Negative infinity until infinity.
Okay. Range. Range.
0 to 1.
0 to 1.
0
Infinity.
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 0 to infinity, which is not including 0 because we have asymptotes here. What is the graph cross y-axis at where? At point what? Cross y-axis?
0, 1.
0, 1. What is asymptotes? What kind of asymptotes we have here? Line of asymptotes here. What kind of asymptotes? We have three types of asymptotes. Horizontal asymptote. This horizontal is line of what? Line
to 0.
Y equal to 0. Become our horizontal asymptotes. Okay.
Sir,
Yes.
may I know what toots?
Huh?
What toot? I
Toot?
need to spell.
Is it can you see that? Horizontal asymptote.
Okay.
Okay. That's for A is greater than 1. But for the case of A located between 0 and 1, you can see A is still positive. But now it's located between 0 and 1. This is the case for A is greater than 1. A must be positive, must always positive. If you look at the definitions, we go back to the definitions of exponential function. Now for A is between 0 and 1, the graph is like this. X-axis, y-axis. Point here is 0.01. This is asymptotes. So what is the domain? Domain.
Negative infinity to infinity.
Minus infinity to infinity. Range. Range.
0 to infinity.
0 to infinity. Across y-axis at what points?
0 and
0, 1. Horizontal asymptote, what line? Which line of horizontal asymptotes?
x axis. Y equals to 0.
Y equal to 0 or x-axis. So that characteristics of exponential functions depends on the value of a here. Depends on the value of a here. Either a is greater than 1 or a is between 0 and 1, but still positive if you look at it. Because the definitions, a must be positive and a must not equal to 1. So either greater than 1 or less than 1, but even though less than 1 must be greater than 0. Because we always want positive. Any questions?
Sir,
Yes.
how we want to know horizontal asymptote?
Horizontal asymptotes is that the line will go approaching that line. Approach, you see. It's going to be approach that line. Approach the line. Line which way they're going to approach this line. Line y equal to 0.
Right, sir.
Cross y-axis, same. At 0.01. Only a method that the shape of the graph is different. This side or this side. But the place of the cross, same. Right. Then we have the transformations of exponential functions. So need to remember back the transformations of functions. In chapter 2, we study of transformations of functions. So same. We have horizontal shift. Horizontal shift. Shift right or shift left. It happened when shift right. It's happened where? When it's happened? Shift left, let's say, or shift right. When it's happened?
X plus C.
That's x plus c.
X plus C will become shift left. X minus C, shift right. Remember that our X, we plus with C or we minus with C. Now our function. And now we talk about transformations. It's definitely Same with the transformations of function. Only that now we concentrate on exponential function. Transformation of exponential function. So we have horizontal shift like the transformation. So when horizontal shift happen, when x plus c or x minus c, x plus c shift to the left, x minus c shift to the right. And then we have also reflection. When we talk about reflections, either x exists or y exists. X exists where? Where is because of x exists? When we need to use x exists of our reflection.
Negative fx.
Negative of our function. Y exists happen when? When we talk about reflection, can be x exists or y exists. These reflections about x exists happen where negative of our function. But y exists happen where negative of x. Negative of x only. Let's say here, let's say the functions is a to the power of x. Negative of a to the power of x. So let's say a to the power of x. So negative of x, that is the reflections of y exists. You see the difference between these two. This one, negative of our function, this is our function. This one, the original function, a to the power of x, but we negative of our x only, and not our functions. So for this case, we reflect about y exists. Reflections. Then we also have vertical stretch or vertical compress. Vertical stretch happen when? Vertical stretch. Vertical stretch happen when? When our functions we multiply with c, and c has a value which is greater than 1. But when c is a value is between 0 and 1, we compress. That's vertical. Vertical meaning that vertical, either vertical stretch or vertical compress. Apart from that, we have horizontal, either horizontal stretch or horizontal compress. A horizontal stretch happen when? Happen when?
C is between 0 and 1.
C is between 0 and 1 for the case of c multiplied by x, not multiplied by our function. Not multiplied by our function, multiplied by x, our c. And c is located between 0 and 1. So for the case of that, every x coordinates must be multiplied by 1 over c. And also we compress. Compress happen when? When c is greater than 1 and each x coordinates we multiply with 1 over c. For the case of c is greater than 0. And remember that we now c is multiplication by x, not multiplication by our function. That's compress or stretch. For horizontally, for vertically, we multiply by our function. C multiply by our function. C multiply by our function. Look at the value of c. Whether c is greater than 1, it's stretch. C is located between 0 and 1, compress. And every y coordinates must be multiplied by c. That's for the vertical stretch or compress. For horizontal stretch or compress, horizontal is C multiplied by X. Remember that, C multiplied by X. So stretch, so every Y coordinates must be multiplied by 1 over C when C is located between 0 and 1. That stretch. Compress when C is greater than 1. And every Y coordinate must be multiplied by 1 over C. That's compress. It's exactly same as the when we study functions, transformations of functions. And remember that transformations of functions, you need to follow the flow. When I look at the open book test last time, I not look at all, right? Only a few. Then when I look at, I can say that you cannot do transformations of functions. Why? Because many of you do not follow the flow. I give you flow. Flow, we have to follow that. Which one to do first, which one to do later. First must be horizontal shift. Then reflections or compressed stretch. Reflections or compressed stretch can be exchanged. You do compressed stretch first and then reflections, or you do reflection first and then compressed stretch. And then the last one is vertical shift. Vertical shift must become as the last one. You must follow that. You cannot go straight to reflection first and then go to number 1, shifting of horizontal. No. That's transformations of functions. So the last one, the last of transformations of function is the last of transformations of function is shifting vertically. Shift to vertical. Vertical shift happen when? When shift to vertical? Vertical shift. Shift to vertical meaning that we go up or we go down. Up or down. When?
Fx plus C.
If Fx plus C is that we go up or we go down?
Up.
Up. When Fx minus C, we go down. Remember that it's our function. Our function Fx, we plus or we minus. No, our x, our function, our Fx, we plus or we minus. That's transformations of functions. So when we talk about transformations of exponential function, it's going to be the same. We have horizontal shift. We have also, this is the first one. The second one, we have reflection. And then we have compress or stretch. The last one, vertical shift. This one can be exchanged. You can do compress stretch first and then reflections, or you do reflection first and then compress stretch. Then when we say reflection, we have two types of reflections about y exists or about x exists. Compressed stretch also we have two types, either horizontal or vertical. You have to look back at the transformations of functions. After you complete all this, the last one is vertical shift. So the process of transformations can be cover all, can be only 3 of them. It depends on the function of our function. Now we're talking about exponential functions. We talk about exponential functions. So the way we solve is same as the transformations that we did before. Questions? Well, the transformation same as in chapter 2, chapter of transformations of functions. Right. Then we have this type of the function, this type of exponential function, fx equal to the e to the power of x. So normally approximately e located between 2 and 3. So the graph of the functions e to the power of x, xy, must be looked. So the graph will be crossing at 0, 1 as well. But must be located between 2 and 3. Let's say if it is 2 here, right? 2 to the power of x. So we have another one. Let's say 3 to the power of x. And this one, e to the power of x. Because e to the power of x located between 2 and 3. E located between 2 and 3. And this type of the exponential function we call of natural exponential functions. Natural exponential functions, and we always we say that it is ln, natural exponential function, not ln, not ln. So base e. So this is exponential function with base our exponential function is e, and e is located between 2 and 3. E located between 2 and 3. This is what we call natural exponential function. So today we just look at the shape of the graph of the exponential functions and what is the characteristics of the graph of the exponential function. Remember that from the beginning of the lessons today, I said that exponential function is one-to-one function. Exponential function is one-to-one function. This is one-to-one function. Why one-to-one function? If you remember back what we called vertical line test, or you substitute x with one value and another x with another value. So you can see that it's 1 to 1. Therefore, this function, exponential function, whether the value here, the value of a is greater than 1, and this is the case of the value of a is greater than 1, or maybe the exponential functions, this shape when 0.01 here, or this is the case of a located between 0 and 1, whether this type, they must be one-to-one function. And when we talk one-to-one function, they must have an inverse. They must have an inverse. And at the moment, we don't want to find the inverse of these functions. Even though that you know how to find the inverse, because remember that the last part of chapter 2 is to find the inverse of a certain function. Only that we know that they must have inverse. We're going to look at the inverse of these functions later. At the moment, we don't want to find the inverse of this function. So you remember back the transformations of the functions. Transformations of the functions, we apply for transformation for the exponential function because that is transformation of functions, regardless of whatever the function. But now we talk about exponential function. Exponential function. So transformation of exponential function, we apply same as transformation of functions, which we have horizontal shift, which we have compressed stretch, we have reflections, we have vertical shift. Now we talk about exponentials. We don't go yet about of logarithmic. We concentrate on this part first. Exponential functions. So remember that when we talk about exponential function, this is the type of graph that we have, where we have asymptotes here. Asymptotes here. We have asymptotes. And asymptotes here. Right. Any questions?
Sir,
Yes.
function of 3x, the initial function of 3x is same with ex. Ex, sir.
No. Different. It's
Different.
ex must be located between 2 power of x and 3 power of x. This just to show the shape, right?
Oh, okay.
Not too important, just to show the shape, because later, if the question say e to the power of x, so you not find that it's never encounter. You encounter this is the graph when we say the graph of e to the power of x.
Okay, sir.
Right. So later, next lesson, we're going to look at another function, logarithmic functions. All right, right. Next lessons, we don't go yet for the logarithmic, right? We're going to look at the examples, more examples of exponential functions before we go to the logarithmic. Right. Any question? If no questions, with that, I close the sessions today. And inshallah, we'll see you back on Thursday morning. And remember that for those who's I call their name early today, early of the class, please do not the same mistake again on the next quiz, the quiz next week, right? You hand in the single file, right? That is understand.
Okay, sir.
Okay, so I close the sessions today with Tasbih Kifara and Surah Al-As. Subhanallah.